Okay, so this is lesson 7B, part 2. So just more of the same from part 1. Here's some examples from there. I'm not sure if they got to the full, I think they mostly did get to the full test, so there's not a whole lot of new stuff in here. So again, we're doing a one sample t-test for mean. And typically, the standard deviation is unknown of the population. I mean, that's just usually true. So we're gonna this one's with data. So I don't think we did one with data the first time around. So this time we're gonna do this with data. Does the data provide convincing evidence that the significance level of aquatic life in the stream is at risk? So this is about the level of dissolved oxygen in a stream river as an important indicator of the water's ability to support aquatic life. The researchers measured the DO, the dissolved oxygen level, at 15 randomly chosen locations along the stream. Here are the results. So they randomly selected 15 of these guys. An average dissolved level is less than 5, puts aquatic life at risk, evidently. So let's keep that in mind. So we're going to start going through this, do the data, provide convincing evidence. So we have to get started, with stating. So state. So mu is the true mean what? The true mean dissolved oxygen level in the aquatic life of the stream. Sorry, the null is going to be, where does it say that? Oh, so anything less than 5. So the null is that mu is 5, right? The mean DO level is 5, but they do think less than. So less than, the alternate is less than there. And again, they said the mean DO level in the stream with an alpha level of 5%. So name the interval. So it's a one sample t-test for mean. Let's check the conditions. So I think it said random sample, randomly chosen locations. So random sample of locations of the stream. Less than 10%. So 15 is less than 10% of all the locations in the stream. And finally, we were hoping for, it doesn't say the population, n is not 30, 15 is not 30. So I really do have to graph this in my calculator. So when you get your calculator out, I'm going to call this DO for dissolved oxygen levels. And I'm just going to type it in. Okay, so to check the condition, I've typed in all 15 pieces of data. Hopefully I did it right. We're going to go to a list in our data statistics page and choose DO. And it looks not very skewed and no major outliers there. I think we're okay. If you did want to check for outliers and you just weren't sure, you could go to not histogram, sorry. You could go to a plot type and go to dot box plot, and it shows you there's no outliers. That's connected over there, so there's no outliers there. For the next step, you might want to do one variable stats on this data. So I'm just going to do that. So menu 611 and choose the do list. So you do have now some information there if we need it to do the do step. So for example, for this one, we could put 4.77. That's our X bar, plus or minus. T critical value. So really, let me just write the next part. So T critical value times the fraction Sx according to that is 0.9396. 9396 over square root of 15, I believe. And so we go back to the calculator and figure out the, oops. So if we go to inverse T, so menu 6, 5, 5, I think. No, inverse T is 6, actually. No, I think I did it wrong. So menu 6, 5. Yeah, inverse t is 6. You're right. Nice. Okay. So because it's I forget the 95%. They didn't seem to specify. Okay. Well, we should probably figure out the t value. I just did a lesson on intervals, and I was thinking intervals, and it's not an interval. So going back to the calculator, we do need that information, though. So let's get that back up. So according to this, we need to get, so x bar is 4.77 minus the mu, which is 5 here, over a fraction us x is 0.9396 divided by square root of 15. So then you would type that into your calculator. Let's see if we can do that. So we have a fraction 4.77 minus 5 over 0.9396 over square root of n, which is 15. So we get t equals negative 0.948. Okay, so we draw our curve. There's negative 1, 0, 1. So negative 0.948. Somewhere on here, you're shading this direction, more extreme than that. And let's just check the, it's less than, so less than. So you are just shading one direction, not both. So then you could get your calculator out and do, instead of norm CDF, you could do TCDF. So it'll be menu 655. Lower bounds negative infinity, upper bounds the negative 0.948. And degrees of freedom is 14, 15 minus 1. And we get a p-value of 0.1796. Okay, so because the p-value is greater than the alpha level, we do not reject. We failed to reject. We do not have enough evidence to prove that the DO oxygen levels are less than 5. Let's see what they did here. And again, they drew the graph. So they had to draw the graph to prove that last one because we didn't have it. So they had to draw it. They drew a histogram. I think dot plots are easier there, but you could draw either one. Be fine. So then we got our t value. We did norm CDF. We got a p-value of 1809. Is that what we got? Just looking. Yeah, pretty close. They had a little rounding errors there. Hopefully we did ours right. Because the p-value is greater than the alpha level, we don't reject. We don't have enough evidence to say that it's less than 5. I think you definitely want to, one thing we did not do, which we need to do, is do the test in our calculator. So you get in the habit of doing this. Menu 6.7 is tests, and this would be a t-test. Definitely data. We called it do, I believe. Let me see. I think I missed it. Oh, I don't have to put that. So the null is 5. The list, sorry, I thought the list was first. The list is the do list. And it was less than, I believe. I think it's less than, so we're going that way. So 0.1809, yeah, that's about right. Degrees of freedom 14. Good. Because we failed to reject, okay, what kind of error could we make? Well, what decision did you make? We failed to reject, right? It was a very high p-value. So we could have made a type 2 because we failed to reject. That's the only type we could have made. If we did, the true mean dissolve oxygen is less than 5, but we didn't find convincing evidence to think that it was. So we failed to reject, but it actually was less than 5, right? So we didn't realize it was less than that. And so the aquatic life is in danger, and we weren't able to identify that. That's kind of a bad error. Okay, that's the lesson for today. You got a practice problem here. I'm going to work that part B. And that's it for today.